Live. Hello, everybody. Welcome to your free GMAT Prep Hour. My name is Reed Arnold. I'm glad to have you here today on this Sunday, February 27th, 2022. If you are watching on the YouTube video later on, welcome as well. If you're looking for other free prep options, we have them. You can take the first class of any of our GMAT courses in online or in person for free. That is 1/9 of the entire package that you don't have to pay a dime for. I always say you should do it no matter what, even if you don't intend to pay for the course, because first off, it's 1/10 of the course. Second off, in that first class, we talk about some big stuff, some huge strategies, some of the biggest things you need for the test, particularly in data sufficiency and sentence correction, typically. We also give like an overview of what the test is, how it works, how it's scored, how to study. So there's just a lot of good advice you can get for no money. No reason not to try a live class. And if you are thinking about, getting a course, scope it out, try out the teacher, see if your vibe clicks, and sign up. We'd love to see you. You can also do the same with our Interact, which is our self-paced video course. You can try the first lesson for free, get a taste of what that program is like. It's a really nifty program. You also get that if you sign up for the full course. So you'll have the course and the Interact. But Interact's a neat program. It adapts to you as you answer. If you seem to be struggling, it'll go to easier questions and dig into the basics more. If you seem to be doing well, it's like, well, let's try a challenge problem. It's just a really nifty way to do a self-paced video course that I don't think I've ever seen before or since. That doesn't mean it doesn't exist, but I haven't seen it. The other thing that I'm psyched about is the Foundations of GMAT Math, which is now free. Do those twice a month or so, usually one day, 1 7-hour session, 2 3.5-hour blocks. Sometimes we do it over the course of a weekend, like half on Sunday, half on Saturday, half on Saturday, half on Sunday. And every now and then we do it split weeks, like half Saturday, half on the first Saturday, half on the second Saturday. Point is, it's free, 7 hours of GMAT Math. It's one of my favorite courses to teach. Even if you find yourself to be pretty strong at quant, I got something. And I've been teaching the GMAT for years when I first took that course in order to teach it. And I learned something and changed some habits on my quant stuff that kind of helped me on the test. So I think anyone could benefit from that. And we really talk about math in a way that I wish it was taught more often, in like a very foundational way, but in a GMAT style of thinking. So I highly recommend that you attend that. And it's all free. So today, in our free GMAT Prep Hour, we are talking about sets, averages, and medians. We are going into quant, and we're talking about statistics, particularly sets, averages, and medians, dealing with these metrics for small sets of numbers typically. We do have a few other free GMAT Prep Hours on statistics. We have a free GMAT Prep Hour on all of them done by Jeff. Uniformly spaced sets, weighted averages, which is a big one. And it's going to tie a little bit to what we're talking about today, but I'm not trying to actually test weighted averages. Go to that video if you'd like to learn more about those. And he also did a lesson on standard deviation, one of the less commonly tested questions, but it does show up. And there are a few predictable ways that GMAT tests that subject. But we're talking about sets, averages, and medians today mostly. And so we're going to do a bunch of question sets, and I'm just going to talk about this question type in a way that I think is helpful for the GMAT. Okay. First thing I'm going to do is I'm going to give you a question set. I'm going to give you 3 questions to do. I'm going to put a timer up for 6 minutes, and you're going to do these questions as kind of a warm up. I'm throwing you right to the wolves. For those of you that are really new to this, just a quick crash course on data sufficiency. A data sufficiency question is a GMAT only kind of question type. You will have a question, you will then have 2 statements, and then you will have these 5 answers in this order all the time. And what you're trying to do is not really answer the question. You're trying to say, where in the combination of these 2 statements, if anywhere, is there enough information to answer the question that is asked, right? So if I can answer the question that is asked here with statement 1's information alone, I would choose, but not statement 2's, I would choose A, which says statement 1 is enough, sufficient, but statement 2 is not. If they're both enough alone, I would say each statement alone is sufficient. Here, the answer to this question, if you're curious, would be C. I need both of these pieces of information to answer the question that is asked. I can't answer the question with either alone. And if it turns out there's no sufficiency, there's not enough to answer the question, you would choose E. So there are some data sufficiency questions. That's how it will work. I will put up this box to remind you what the answer choices mean. 1 alone, 2 alone, together, either, not enough. So that's data sufficiency crash course. Probably not nearly enough if you're really new to this, but we got to get going. I have 6 minutes on the clock. If you have a phone or something yourself, I would use that as a timer. 3 questions, ready, set, go. All right, gang, that would be 6 minutes for this set. Go ahead and just take a second and analyze your decision making. Did you get stuck on one you maybe shouldn't get stuck on? Should you have moved on? Whenever you do a set of questions, one of the first things to decide is to look at is your decision making. The test forces decision making. Sometimes you're going to have to skip a question, and by skip I mean make a guess of the letter and move on. Don't matter how good you get, the test is going to adapt to you. So just always make sure that you're okay moving on. Make sure you're comfortable moving on. You can't let missing questions feel like a failure, because you're going to miss a third to half the questions on the actual test pretty much no matter how good you get. And if that feels like failing, you're going to feel like you're failing a lot, and that's just not a mindset you want to be in. So really steel yourself to this. Remind yourself that it's okay to miss. It's expected to miss. It's part of the game. Now let's talk about these one-on-one. So let's start with this first question here. Okay, at an auction, 6 race horses were sold. The average price paid for the horses was $17,000. The prices paid for the first 5 horses were those numbers. What price was paid for the final horse? Go ahead and send in the chat what answer you chose for this question. Just see what we got. If it was a guess, put a question mark by it. That's fine. A C and A C with a question mark. So I have a few C's and an A, a few holdouts. It took a confession that it took too long, but we got an answer of C. Yeah, it probably did take too long, JD, and I suspect you're not alone, even if for those of you that also chose C, spoiler, C is the right answer. But like I just said, I'm less interested in right answers when you're studying. I'm interested in improvement. There's no reason to fear being wrong, and it's often a good place to learn. So I specifically designed this question, but it's based off of a question I've seen on an official test. And it really is going to introduce, I think, one of the key ideas of today's lesson when we're talking about averages, sets, and medians. I suspect everyone's first instinct, to some degree, because it'd probably be my first instinct too, would be to answer this question using the average formula. What is the average? Well, let's add up the numbers, divide by the number of numbers, and you have the average. So I suspect some people like set up an equation here where they did 15.5K plus 18K plus 16.3K plus 19.7K plus 14.8K plus the number we're not sure about, and divide that by 5, yada, 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 right? And that needs to equal 17K. Yay, I mean, that is an approach. You could do that. But I suspect that arithmetic kind of bummed us out. It's not, the worst. It's not undoable, and it's probably good practice to do it. Yes, thank you, JD. Divided by 6. Yeah, right there, 6 horses. It's not, undoable arithmetic, and it'd be good practice, but we might be able to find a better way to get through this question. There might be a sneakier approach by really getting into the understanding of what an average is. What is an average of a set? I want you to think about that for a second, right? Not the formula. Average is sum over number, but what does that tell us? What does that mean? Just go ahead and try to answer. You can type in the chat if you want to try to answer that for yourself, or you can just answer in your mind if you're at home watching on the recording. Just think about that. We use this all the time, average, but what are we actually saying when we use that word? What are we trying to tell people? There's kind of a sense that, like, it's like the normal number in the set. But we all know that you can actually have a set where no actual entity in the set is that value. So you can have an average that nothing has. Yeah, Krupa, it is the sum of the terms over the number of terms, but why are we doing that? What is the purpose of that? What is it telling you? It's not the most common number in the set necessarily. It's not the typical. I mean, you can have a set where things are so far from the average it's crazy. What the average is meant to tell you, there are 2 ways you can kind of think of it, I think, that are useful. The average is the value that each value would be if they were all equal. It's the great equalizer. If I take this set and I make every value the same, this is what that value would be. So in this case, if I say the average price of 6 horses was $17,000, I don't know what each horse was really, but if I take them all and treat them as if they were the same price, it would be 17,000 a horse. An average is a rate in many ways, the price per horse. But of course, the truth is that those actual prices can be all over the place. The average is kind of a ghostly figure. It's a representation. It doesn't necessarily, and in fact, very rarely, is the thing that every number in the set is. But it's still useful, and we can still use it to make determinations. For instance, if I know the average of the set is $17,000, and I know one horse was $18,000, so I know that, I can make an inference about at least one horse. What can I infer about at least one horse? So Taha says it's 16,000. Do I know that? I don't think about this for a second. Do I know that at least one horse costs 16,000 if another horse costs 18,000? Yeah, good, Piyush. The thing I know for sure is that one of the horses is less than 17,000. If one of the horses is over 18,000 and their average is 17,000, I need at least one horse to be less than 17,000. Now, Taha, if it is only one horse, then yes, it would be 16,000 if it's only one horse. But there could be multiple horses that are less than 17,000. I just know one is. Now think about why. Why do I know that? This is getting to so the average is the thing where if every item was the same value, but there's also another way to think about it. Why do I know if someone is above the average? At least one thing must be below the average. Let's imagine it was 2 horses that I knew were below the average. Well, what do I know about those 2 horses? You know, the overall average is 17,000. 1 horse is above the average at 18,000. 2 are below the average. What would I know? Yeah, good, Taha. Their average would be 16.5. It's really an average. It could be that they both cost 16.5, but really it's that their average is 16.5. I don't know their specific price, but I know the average to 16.5. Why? What is this? The average is the place the set balances. If I treat every number the same, that's now the balance point. And if something goes over that balance point, something else must go below that balance point in the same amount at the end of the day so that everything balances out. Well, Jaydeep, if I specify that, so Jaydeep's asking what is the min max of those 2 horses? If I've specified that they both are less than 17,000, one could be 16,900, basically 17,000, let's say, and the other would be, I gotta think about the balance here. It'd be about 1,500. I think that was right. I did that quick in my head. If I don't, like, here's a possible example, right? It could actually be 16.1 and 16.9, but those 2 averages balance at 16.5. And so with the horse at 18,000, those balance at 17,000, where the set untold balances. Okay. Now, the truth is, if I don't actually give a limit for what those horses are, they can be, you know, if I just know one horse is 18,000 and 2 horses are not 17,000, there's a wide range of possibility here, but their overall average is going to be 16.5. But that's if the other 3 are the average. I should probably have made these like solid. If these 3 are also variable, who knows? It gets a little wonky, right? I could have 3 horses at 13,000 and 3 horses at 21,000, and there's no actual average horse at 17,000, but that's still the average. That is still the place that set balances. Or I could have 3 horses with an average of 13,000 and 3 horses with an average of 21,000. and the overall average is going to be 17,000. Because it's like if I treat these 3 horses the same, they'd be 13,000 a horse. If I treat these 3 horses the same, they'd be 21,000 a horse. Overall, that's like each horse is 17,000 if I treat all the horses the same. This is a weighted average. If you want more on like weighted average questions that deal with the average of one group and the average of the other group, watch that video that Jeff taught. It's a good lesson. We're touching on this today because the fact that the average is a balance point gets us into like weights in the set. But I just want you to start thinking about the average as a balance point. And it can get crazy, right? I could have one horse that's $97,000. It's, you know, Secretariat's offspring. And then I have 5 kind of gamble horses that are cheap because who knows how they're going to end up. They're each $1,000. But if I treat all the horses the same, it's 17,000. Of course, that's not really representative of the group. This is why averages are not always actually the best metric to gauge a group, because the variability can be huge and it's not clear. 2 sets can have an average of 17,000 and look drastically different. But it is the place those sets balance. Okay. And again, those 5 horses, maybe they don't even have 1,000 each. Maybe they're an average of 1,000 each. Some of them are $2, some of them are more. It's all about balance. Now, get that in your mind, because that's going to be a major thing moving forward. That's kind of one of the main thrusts of today's lessons. We can use the idea of the average as a balance to answer questions. Let's go back to our problem here with our 6 racehorses, the actual situation we had. Because we were actually given 5 of the horses. And we given the balance point of 17,000. Instead of adding up each of those individual 14, 8, 15, 5, 16, 3, 18, 19, 7, let's use the fact that 17 is the balance and figure out how many times are we over the balance and by how much, and how many times are we under the balance and by how much. Because at the end of the day, the set has to balance. Well, 14.8 is 2,200, 15.5 is 1,500, 16.3 is 700, under that 17,000. 18,000 is 1,000 over, 19.7 is 27 over. So if I add those up, and that's a little bit easier to add up than the actual prices of the horses, I find out that the horses that are under the average are 4,400 too low, and the horses so far that are above the average are 3,700 too high. But the set needs to balance. I can't have 4,400 under and 3,700 over, because that's not balanced. I need to have 4,400 over and 4,400 under, or 3,700 over and 3,700 under. So in order to make this set balance, this final horse needs to be 700 over to balance this set. So we got to get it 700 over, which would be C. 17,700. Okay. And that's one of the main ideas today, is you don't have to always use the average formula to figure out like things about balance point. Right, JD, minus 4,400 plus 3,700 is still minus 700. So I need a plus 700. The plus 700 fills that gap. If I add one that's 16.3, I subtract, I'm now minus 5,100. I'd be even more lopsided. I need the amount under the balance to match the amount over the balance. Right now I have 44 under the balance and only 3,700 above the balance. I need another 700 above the balance. So it's got to be plus 700. Okay, so you can do this without actually having to add up these gross numbers. And this is going to be a concept we're going to see a few times today. It's just a useful thing to know about set building. So Kanya, probably low 600s, I suspect. I suspect the arithmetic would trip people up, but enough people could power through it to get it. You know, even if they weren't 700 level scores, it's still a gettable question. But the 700 level score does something like this instead of using the average formula. Not that you can't practice the average formula. I think it's a good thing to practice, because that arithmetic, you know, it's good to do, but no, JD, I would not say this takes the same time as algebra. I would say this is much easier than the algebra. Because to add up 14.8 and 15.5 and 16.3 and 18 and 19.7 is just much harder than getting these numbers. unless you're a computer. If you're a computer with arithmetic, as some people are, I'm not, then maybe it's as fast with algebra, but no, I think this is a much faster approach. And much less likely to make a mistake in the arithmetic and much less cognitive load. It's just, there's a lot of benefits to this kind of thing. And it's going to help us in other questions. This understanding of averages as balance is about to help us more. So let's take a look actually at this next question here. The average of 11 movie theaters at a Cineplex. Man, it's already 12:35. We got to go. 2, 3, 4, 5, 6, 7. While I'm doing this, send in your answers. 7, 8, 9, 10, 11. Let's see where we fell here. This question is more a question of what I call set building. We're building possible sets of values here. Okay. So I have a B and an E, or a B alone. Let's take some guesses. This is a hard question. This is harder than the previous one, I suspect. An A. I think there's a way, if you have a good set, if you have a good understanding of averages as a balance, it's easy to make an educated guess on this question, a pretty educated guess. I'll explain what that would be before I show like the pure way of getting through this problem. But if you are in a rush and you kind of just want to make a quick guess, I think there's a way to do that. First thing to note, okay, how many items are there? We're told the average number of seats is 53. And we're told the median is 58. And the median is the middle number when we put the things in order. 4, 5, 6. So that'll be this right here. This is the middle value. And since this is an odd number, this is always worth checking. If it's an odd number of numbers, the median is in the set. It is that middle number. If it's an even number of numbers, you have to get the average of the two in the middle. But since here the median is 58 and there are 11 items, that sixth number is going to be the median. Okay. And that tells us something. That tells us that all of these numbers to the right are 58 or more. And do note that they can be 58. There's nothing that says this theaters can't have the same number of seats. So these all could be 58 maybe, but they're 58 or more. They're not less than 58. And all of these numbers are 58 or less. They're not more than 58. Okay, so that tells me, this gives me like a stopgap in the middle of the set. That tells me something about those to the right or the left. And the average is 53. Now, I'm never going to do 53 times 11 here. I'm not going to use that arithmetic. I'm going to use this idea of sets as balance, as averages as balances to work through this. When I know 58 is in the set, that tells me that one of the theater has exactly 58 seats. I do know that. That has to be true. So anything that doesn't have 3 is gone, and that's only C is the only choice that has only, that doesn't have 3. Okay. Now at this point, this is where I think an educated guess can come in. I know that the median is 58, so I know all these are 6 theaters over here that have 58 or more. But I know the overall average is 53, which is less than 58. So the balance of this set is less than 58. Well, how am I going to do that? How do I get the balance less than 53? I got to have some theaters less than 53. Right? That's how you make it balance. If some are over the average, as these 6 are, at least one has to be under the average. And it's a pretty good skew here, right? 6 above 58, 58 or above, that's over half the numbers. You know, I have a sense that I'm going to need quite a bit of pull to get this average back down to 53 here. And so that makes me look at number 2 and suspect that that is the answer. Just suspect that this needs to be true. I don't know if you need the at least. The GMAT might say at least 1 as opposed to exactly 1. I probably, for clarity, I made this question up. I probably should have used at least 1 theater. I'll make that addition. But I think if the GMAT gave this, I wouldn't call it unfair. Because it's true that one of them this is going to be true. Okay. So since the balance point is less than the median, and all of these numbers are the median or more, I need to skew down. I need to get, remember, the average is here. Anything over the average has to be matched by something under the average. It's the balance point. So if these numbers are all more than 58, all these numbers are 58 or more, but the overall average is 53, I got to get some numbers less than 53, and quite a bit less than 53, because 58 is 5 more than 53, right? I got to get this balance down. And since I know the average needs to be skewed downward, number 2 looks pretty good to me. That at least one of the theaters, or one of the theaters certainly, must have fewer than 48 seats. In order to get this average down to 53, I think that's probably going to be true. I don't think number 1 needs to be true. I don't think I need a theater with more than 60 seats, because the average is pulled that way. It's pulled lower. 60 is trying to pull the average even more higher. There's no reason to do that. There's a good reason to try to get the average pulled lower. Also, like if you were tempted by A, that's just too easy. It's too easy to see that 58 is one of the numbers. And so that's kind of like the trap, like, ooh, I feel good about number 3, but I really don't know how to handle 1 and 2. So I'm going to choose 3 alone. I call that a lifeboat answer. You want to avoid lifeboat answers, the things that feel just like too safe. The GMAT wants to reward hard work, and that safety cling to the one that's clear is often not a wise guess. So that's my guess, right? My guess is that it's going to be D, if I had to do this quickly. Now, to show purely that the answer is D, because, is 48 really, do we really need them to be 48, or could they all be 50 and above? Do I really have to have one be 48 or above? Well, let's think about this. We're trying to figure out if one of them must be fewer than 48. So we might think, let's try to make these numbers as big as possible. We want these numbers to be as big as we can possibly make them. Because then if we make them as big as possible and they're all above 48, number 2 doesn't have to be true. Okay. Well, if we're going to make these as big as possible, what are we going to do with these? Keep in mind, the average is a balance. Yeah, Sukanya. If these are going to be as big as possible, we want these to be as small as possible. If we're going to maximize these, we're going to minimize these. And this is a common thing to do with sets, test the extremes. It's a common thing to do on the test in general, build some extremes. And so I think the extremes here, to minimize these, well, they can't be less than the minimum or less than the median. So let's make these all 58. Let's do this bigger. If we make these all 58, we've minimized the bigger numbers. Well, let's think what that's done to the balance. If the balance is 53, and all of these over here are 5 bigger 6 times, I'm 30 above my balance. So in order to get back to 53, I got to be 30 under that balance. So let's think I just distribute it amongst, let's say I distribute this evenly. Let's say every one, okay, so 30 divided by the 5 numbers would be 6 under the average. That would be 47. I could make every number 47, and that would be 30 under the average and 30 over the average for a balance at 53. And in that case, I have a theater with less than 48. In fact, I have several. And if I make those any bigger, it undoes the balance. If I ratchet those up, I can't ratchet these down anymore because the median is a block point. And so if I ratchet these up, the balance skews. I need plus 30 and minus 30. If I make these closer to 53, then it'd be plus 30 and minus 25 or something. The balance wouldn't balance, and that blows the question. And so you might be able to make some of these bigger, right? If I make these bigger, if If I make these 53 or 50, here's the problem. Every time I add one, the balance has to balance. Some of these have to get smaller. If I make these bigger, the smallest one just gets less than 48, less than 47, less than, and so then it's less than 48. Okay. This is a hard question, but it's just a good demonstration. Like, I'm not really going to do arithmetic here. I'm not going to calculate the average, do 11 times 53 and work. Maybe you can, I don't even know. I'm going to use the idea of a balance point on the set to figure out, okay, how many are above the average? How much are they above the average? How much does that pull the average this way? I need to pull it back this way by the same amount. So JDPI, I just divided that 30 by 5. If all of these on the small side of the average pull the average down equally, they'd each be 6 under the average, 30 divided by 5. That's the most extreme case. Now, maybe some of them are more than 47, but if some of them are more than 47, the smaller number's got to be less than 47. So someone's going to be less than 48. I can't build a set where they're all 48 or above. Isn't there any other way to maximize other than the way you did it? How do you mean, JD? I don't know of another way. If you try to build a set where none of them, if you try to build the set where you're like, okay, I'm going to make all of these, I'm going to make sure none of the theaters has fewer than 48 seats. I'm just going to make all of these 48, in fact. And so no theater has below, 48s all around. Okay, well, that's -5 from the average 5 times, because there's 5 theaters, -5 from 53. So that's -25 on this side of the average. But then if you consider these are going to be at least +30. That's the most extreme case if these are all 58. If these start to get bigger, it's more than +30. So even in the most extreme case, I don't have enough on the small side to balance out the set. If I make them all 48, I don't have enough to balance out the high side. So it has to have someone less than 48. But JD, if you make the right-hand side larger, you undo the balance even more. It's already 5 over. We're already 5 skewed to the larger side. If I make this large side larger, that just makes it even more skewed to the larger side. I need to make these numbers smaller to get this to match the 30. Remember, if everything, let's go back to the horse, right? As soon as something is above the average, at least one thing has to be below the average. That's the balance, what it means to be a balance point. Okay. And if a bunch of things are above the average by a certain amount, something else has to undo that amount on the lower side. It must balance. You must end up with the same amount below the average, the balance, as you have above the average. Get the difference from the average for each value and add it up, and that has to be the same. So I'm gonna move on here. Some set building tips, because set building questions are not uncommon. The median is a fixed point in that set. You can't have the bigger numbers past that median, because then it's no longer the median. You can't have the smaller numbers past that median, because then it's no longer the median. It is a fixed point in the middle. It gives you a fixed midpoint that some numbers can't be smaller than and some other numbers can't be bigger than. The fixed average is a fixed sum. Anything added to one place must be taken away from somewhere else. Anything taken away from one place must be added somewhere else. You can do it 1 for 1, Or you can do make one a lot bigger and then make two a little bit smaller, or make one a lot bigger and three a little bit smaller, whatever it is. You have to, anything you add gets taken away. The sum can't change. If you add 10 and you don't subtract 10 from somewhere, the sum doesn't change, or the sum changes, and therefore the average changes. Can't do that. Average is a balance point, keep it balanced. So that as a consequence of this, if you're trying to make some numbers as small as possible, make some other numbers as big as possible. If you're trying to make some numbers as big as possible, make some other numbers as small as possible. That's the balance that's the balance idea in motion. If these numbers need to be as big as possible, this one needs to be as small as possible to balance, or vice versa. And as part of that, go extreme. Okay, I'm not going to talk about this last question yet, and you'll see why shortly. We'll kind of wrap this up. So, that'll be kind of one of the last things we tie together. I'm going to give you all a new set. 3 more questions, 6 more minutes. Try to use what we're talking about here. Ready, set, go. All right, gang, that is 6 minutes for these 3 questions. You might have noticed that third question is very similar to the one before. And that's why we didn't go over it then. And we're not going to go over it yet either, because we're going to see a third incarnation of it. Let's start with this first one here. Every person in a certain yacht club. Go ahead, send in your answer for this one. What is the median number of yachts owned by the members in this club? I have a C, I have an E. Okay. An A. 3 people's answered, 3 different answers. It's always fun. So if I were doing this on the test, specify my givens, everyone has at least 1 yacht. Can be a member. I want the median number of boats owned. That is a value question. There's not much in the way of rephrasing here. I just, what is the median? It's that middle number in the set, that, what that middle number is. Statement 1 tells me that 38% of the members own 2 or more yachts. Okay, well, but how many members are there? 2 or more, that, there's a lot of numbers more than 2. How could I possibly know the answer to this question? Well, let's visualize this set for a second. The minimum number, whoever this first person is, how many yachts do they own? One. They own 1 yacht, because everyone has to have at least 1. So the smallest possible owner's 1 yacht. So imagine there are 100 owners. 38% of the members have 2 or more. Well, if 38%, if there are 100 members, I'd have 1 yacht all the way to that 62nd member. And then the 63rd member would have 2 or more. And that would go all the way to 100. I don't know what, might be, that person might own 3 million yachts. I don't know. But do I know anything about the median now? The median is somewhere here. The median is the halfway point. It's the middle, the 50th percent. And so since I know that the 50th percent is 1, I know the 50th person, the 51st person, the 49th person, I know all of those are 1. The median is going to be 1. This is sneaky suspicious, but you need to visualize the set if you can, even a weird set like this. Think of what the set actually looks like. Pick 100, it's a good place to start. We're going to have 62% of the yacht owners have only 1 yacht. The other 38% have 2 or more. They could have a lot, but that midway point, the middle is 1. The median is 1. Okay. So number 2, there are 450 members in the club. That doesn't help us. We have no idea if each of them own 1 million or if each of them only own 1 or what. Could have 450 members with 2 yachts each. Could have 450 members with 1 yacht each. Some could have 1, 2, 3, 4. No idea what the median is from statement 2. The answer here is A. It's sneaky, but visualize the set. Find that where that middle would be. Just because you don't know, and this is very common GMAT stuff. Just because you don't know everything doesn't mean you can't answer what is asked. If they asked what the average is, I'd have no idea. Couldn't tell you. If they asked what the maximum is, couldn't tell you. But I can tell you the median. Make sure you do as much as you can to answer what is asked, and don't worry if you don't know everything. Very common to be able to answer a question without knowing everything. Visualize the set. Build the set. Okay, The second question in this set, another set building exercise. We have 6. Yeah, JD, if it said, what if 50% own 2 or more yachts? That would be a problem. Because then does that 51st person or that 51st% do they each own 3 or 3 million? Those are all 2 or more. So that would not be sufficient. So we have 6 restaurants that this owner owns. We know the median is 30. Well, this is a little bit tricky here because this is actually an odd number of sets, or an odd number in the set. But we know the midpoint here is 30 of these 2 in the middle. And the average is 32. So it's a little bit skewed high. Okay. Now, this is an important piece of information. No 2 locations have the same number of employees. So that they tell us here that all the numbers are different. JD has said 49% own 2 or more yachts. That answer would probably be A. I don't think the GMAT would do that though. They might, but that seems a little too like, what does that mean? So we know all the numbers are different here. That's important. What is the minimum number of people that could be working at the location with the most employees? So we want to minimize the maximum. We want to make this as small as possible. Well, as we said before, that means we want to make everything else as big as possible. Okay. And so if I'm going to maximize the other things, okay, so let's start here with the middle. If I'm going to maximize these, I want to make this 29 so that this can be 28 and this can be 27. These 2 are going to average at 30. That's fixed. But if I make this 28 and 32, that's just going to push this number to be bigger, and it's going to make these numbers smaller. And I'm trying to maximize these as much as I can. Okay. And if I want to minimize this one, but I want to maximize this one, what's the biggest number this one could be? If this is whatever the number this is K, what's the biggest number this could be? I see some number answers. I would say right now, since I don't know the answer, I would say K minus 1. Whatever, it's 1 less than the maximum, because they can't be the same. Right? It's 1 less than that maximum. If the average is 32, I'm minus 1 here, minus 3, minus 4, and minus 5. So 9, 12. I'm minus 13 overall. I need to get plus 13, where they're only 1 apart. What's the best way to do that? Plus 6 and plus 7. This isn't going to work. I don't think actually. Yeah, that works. Yeah, 39. I'm realizing now I didn't do this well. This was a different problem than I thought it was, and I'm kind of winging it. I've forgotten which one I gave you. But I think that checks out. We want to maximize every other number in this set. Well, the biggest number this can be is 1 less than the maximum, which is what I'm trying to minimize. So let's consider that this is 1 less than that. Figure out how many are below that average of 32. Right now, that's all of these. They're 13 too low. So I need to get 13 too high to balance out at that average. Well, if it's 13 too high and they're 1 off from each other, one's going to add 6 and one's going to add 7 to that average. So it'd be 38 and 39. Again, you could do the actual arithmetic, but why? So it's just another exercise in set building. The median is fixed. It's a little bit trickier here because it's an even number of numbers. I just threw that wrinkle in. To be fair, I've never actually seen that on a GMAT problem. So I don't know if they would ever actually do this, but if they did, same idea. You just think about the 2 in the middle as fixed. Okay. Now, if I made this 28 and 32, that would just make these smaller, that would make these bigger, so this number would have to be bigger, and I'm trying to minimize this number. JD, if I don't have time to answer that question, I'm afraid. Okay, so set building, if you're going to minimize something, maximize other things. And use the average as the balance point. This last question, we're not going to talk about yet. I'm going to leave it for later. We're going to do one more question set. This one has 4 questions on it. Okay, I'm going to give you all, maybe 7 minutes, mostly because I have a student soon, so I can't give a full time. But also this, sometimes when I give a question set to students, I actually take a little bit of time off to really facilitate the decision-making aspect of the test. It's not uncommon, for instance, to have 4 questions left and only have 7 minutes or 6 minutes. In fact, I'm probably gonna do 6 minutes. That's not, and you're not behind pace. You've just, you have 6 minutes left. As long as you're within 3 minutes, a 3-minute window, that's okay. So if I have 4 questions left, 8 minutes is like perfect pacing, but as long as I'm within 3 minutes, that's okay. So if I have 4 questions left and 6 minutes, all that just means is I just got to make a decision as I'm moving through. I got to make sure I don't, really overinvest in a question I shouldn't, make smart decisions. That's not an uncommon place to be in. And it's worth practicing so that if it happens on the test and you find yourself with 4 questions and only 6 minutes, you don't panic. You're not like, oh no, I'm going to not answer a question. You're just, you know what it's like. You make a decision, you move on. So here I'm going to give you 6 minutes for 4 questions and make wise decisions. That's a big part of this set. Oops. Sorry if I changed that. Hopefully that hasn't been that way for a while. Had that screen been up for a while? That other question? Or were these four up for most of that time? I hope I didn't change the screen without knowing. I didn't see anything on the chat. It's not like people were letting me know. 20 seconds or so. Okay, take an extra 20 seconds to finish up whatever question you were on when I messed up and changed too early. Okay, now let's go over these. 4 questions, 6 minutes. I don't expect you to have gotten through all of these. If you did, great, but that's pretty tough. I mean, it's kind of a subjective question. If you were to ask me which one of these I feel is most skippable, I'd say this first one. This first one's pretty tricky. You know, I suspect it would be easy. I don't know. I suspect it would be easy to get sucked into this one a little bit too much when it's just like, I should just move on, get through the last 3, call it a day. Right. So if you found yourself in that position, I suspect that's, I put that one first for this reason. I usually put hard ones early to really force that decision-making aspect to get kicked in, because it's a big one for this test. But let's go over it here. So we set E contains the integers 17, 50, 20, 53, X, and Y. And I haven't mentioned this yet, but when you have a set of numbers and variables, the first thing to do is put them in order, especially when you're dealing with medians. Now, how do we put them in order when we don't know what X and Y is? Good question. I leave them kind of floating above, because like, I don't know exactly where those fall. But of the numbers I have, this is the order. And I want to know the median of set E. Okay. This is probably a good median. The value, it's a value question. There's not a lot of rephrasing. You might add these up and figure out what their average is, just because you're kind of curious, like, what is the average of these 4, since I'm going to be dealing with averages, and you'd find that the average is 35. And that doesn't tell you much up front, but it might make you kind of look at number 2 and be kind of curious about number 2, to say the average of X and Y is 35. And I think this is a good situation where starting with statement 2 is a good idea. It seems the easier one of the 2 statements. So let's say the average of X and Y is 35, X plus Y is 35. Or I guess X plus Y is 70, X plus Y over 2 is 35. By the way, go ahead and type your answers for this one. How did I calculate 35? Well, I knew it. I actually didn't calculate it, JD, but I just knew it was 35. Because I made the question. But 20 plus 50 is 70. 53 plus 17 is also 70. So it's 140 divided by 4 is 35. Well, if 2 numbers, if the average of 2 numbers is also their midpoint, right? That is the middle of the 2 numbers. And so if I have the middle of X and Y is 35, well, maybe they're both 35, right? Let's test some cases. Let's consider some possible sets. Maybe it's 17, 20, 35, 35, 50, and 53, in which case the median is 35. Or maybe this number goes a little lower, but in order to keep their average as 35, this number has to go up the same amount. And so that middle is still going to be 35. It could be 34, 36, or it could be 30 and 40, but that middle is still going to be 35. And then that's going to keep going, 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 until eventually these aren't the middle numbers anymore, whatever these X and Y, right? Eventually these X and Y are outside the 20 and 50 range, but if they are, then the median is the middle of 20 and 50, which is 35. So the median of all the sets where X and Y's average is 35 is 35. This statement is sufficient. And now you might kind of notice that 17 and 20 are 3 apart, and 50 and 53 are 3 apart. And that starts to make me think about balanced, perfectly balanced sets, perfectly symmetrical sets. Jeff did that lesson on consecutively spaced sets. And consecutively spaced sets are perfectly balanced. And in a consecutively spaced set, or any perfectly balanced set, the median is the average. And that's what's going to happen here. These two numbers perfectly balance around 35. These numbers balance at 35. These numbers balance at 35. So the median is going to be 35. And the average in this case. And that's going to help you with statement 1 too. When you realize the average of the set is the same as the average of these two, it puts you in the same kind of mindset here. Now, you might do algebra here. You might say, okay, I have 140 plus x plus y divided by 6 equals x plus y divided by 2. And then you could say 280 plus 2x plus 2y equals 6x plus 6y. And then you could get your x's and y's together and say 280 equals 4x plus 4y. Divide everything by 4, and you're going to get 70 equals x plus y. Well, that's actually the same information that statement 2 gives us. X plus y is 70. And so statement 1 ends up giving us the exact same information as statement 2. And so the answer has to be D in this case. Statement 1's a little bit trickier to see. Algebra might be the best way to see it. But you also can just think of like, well, okay, if the average of the overall set is the average of these two things, whenever you remove, let's think about this actually, let's go back to the horses for a second. If I have 6 horses whose average is 17,000, where's the 6 horses? Yeah. So if I have 6 horses whose average is 17,000, if I know 2 of these horses have an average of 17,000, if I remove them, my average stays the same. These other 4 average is 17,000. The balance isn't changed because I've only taken, either I took 2 that were at 17,000 or I took 1 above and 1 below, because these 2 also balance at 17,000. So as long as you're adding numbers that keep balancing to 17,000, the average doesn't change. And so here on this question, if I know the average of the set is the average of these 2, I can remove those 2. And that's going to keep the average the same. So whatever the average of these 4 is, must be the average of these 2. That average is 35. That's what statement 2 tells me. We just saw that was sufficient. So statement 1 also has to be sufficient. The answer here is D. This is a tricky question. I suspect 700 plus. Yes, good point, JD. The question is about the median, but as we saw, if the average of x and y is 35, then every case, the median is also going to be 35. That is a good point, though. Because these numbers are actually perfectly balanced. They're not consecutive, but they are perfectly balanced, right? 20 and 50, though their average is 35. 17 and 53, their average is 35. And so that means the median is also 35. They're balanced perfectly at that midpoint. And x and y are also perfectly balanced at that midpoint. So the median is going to be 35. Second question in this set. The largest number in a set of 22 consecutive integers is 105. How many numbers in the set are less than 90? Well, I'm just going to show you what the trap is here. The trap is to say, oh, okay, 105 minus 22 equals 83. 3, 4, 85, 86, 87, 88, 89. 83 minus 90 is 7. So 7. But that's actually something you want to look out for here. Okay. I say there are 22 consecutive integers in this set. If I start at 83 and my biggest number is 85, and I have consecutive integers in between that, right? 84, 85, yada, 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 dot, 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 all the way to 105. That's going to be 23 integers. You might remember a formula, last minus the first plus 1, to figure out how many integers are in a set. And so that would be 23 integers in the set. But I'm told I have 22 integers. And what's going on here, something I have seen in questions before, it's the difference between the range between numbers and the number of numbers in the set. If I start at 83 and I end up at 105, right, I'm adding 22. 83 plus 22 equals 105. That 22 tells you how many jumps I make. Right, I make a jump to get to 84. I make a jump to get to 85. I make a jump to get to 86. And I'm going to have 22 jumps, 22 gaps. I want 22 numbers. In order to have 22 jumps, you need 23 numbers. In order to have 22 numbers, you need 21 gaps. There's always one fewer gap than numbers, right? Which makes sense. If I have just the numbers 1 and 2, there's only one gap and there's two numbers. If I have 1, 2, 3, there's 2 gaps and 3 numbers. If I have 1, 2, 3, 4, there's 3 gaps and 4 numbers. There's always one less gap than there are numbers. And it doesn't matter how big the gap is. Right now, I'm just considering consecutive integers. It could be multiples of 3, right? 2 gaps of 3 numbers. 3 gaps of 3, 4 numbers. There's always one fewer gap than there are numbers in whatever consecutively spaced set you're dealing with. And so the first number in the set is not 83, it's actually 84. And so I want to figure out how many numbers there are from 84 to 89, not 5, careful, same problem, it's 6. 84, 85, 86, 87, 88, 89. So don't mix up the range with the number of numbers in the set. They're related, but they are different. And yes, there are some questions that directly test this. Okay, this is a dense lesson. We got a lot. It's going to be a good one to come back to. A lot of good lessons here. I'm patting myself on the back a little bit, but these question types are fairly common. Set building, considering sets of numbers. And I realized that we never really had a lesson directly dealing with it, so I hope you find this useful. If the median of a set of p consecutive, notice this, consecutive, odd, positive integers. Notice the specificity there. So it's a set of odd positive integers. We're told that the median is 14. Well, the first thing to notice is that 14 is not an odd number. It is not in the set. So what does that tell me about the number of numbers in the set? There's an even number. If there's an odd number of numbers, the median would be one of the numbers. It would be an odd number. But since it's an even number, I know there must be an even number in the set. So 15, 13, and 3 are already out. It's got to be 10 or 16 here. Now you might just have an inkling if you specify positive at this point that maybe 16 is too big, because that's going to be the problem. It's going to need to be 10, 13, 11, 9, 7, 5. Right, 5 odd numbers less than 14, 5 odd numbers more than 14. If you go to 16 numbers, if you add 6 more numbers, I'd end up at 3, 2, -1, and -1 is not allowed. Can't have a negative number. So 16 is too big. 10, you could have 12. If 12 was an answer, it'd be the answer, but you can't have 16 or more. Has to be an even number less than 14, I think. 3, sorry, not 3, 2, -1, 3, 1, -1. Yeah. So this is just set building under the constraints. Just pay attention to the constraints and build the set. And note that difference between an odd number in the set and an even number in the set as to how it pertains to the median. All right, and finally, last but not least, we're going to wrap this up with our discussion of all these questions here, because they're all very similar, right? We all started with the exact same question, in fact. Set contains these numbers and X. Is the average greater than the median? They're all different versions of this thing. So let's start with the first version of this question we had, which was here. And I think the thing about this is we can kind of do a little bit of pre-work on this problem. You don't have to, but I think it's going to help. First off, like I said, put the numbers in order. We have 1, 4, 8, and 10. And then I have X floating around. So my average is going to be 5, 13, 23 plus X divided by 5. And I want to know if that is greater than the median. Well, let's think about the possible medians. It depends where X goes. Either I have a situation where X is 1, 4, 8, 10, and X is more than 8. I don't know exactly where it is, but it could be if it's more than 8 and 8 is the median. That's one possible set. I don't know if it's more than 10 or less than 10, but it'd be 8 or more, because that would make the median 8. Or I could have a situation where X is the one in the middle, 1, 4, X, 8, 10. And then X is the median. It's from 4 to 8. Or X could be less than 4. And 4 could be the median. Those are the three worlds you're dealing in. And you know the average is going to be this. You always know that's going to calculate the average. So it's like, okay, well, if X is less than 4, is this thing greater than 4? Is the average greater than the median 4? If X is between 4 and 8, you want to know if that thing is greater than X, whatever X is. That's the weird one. Over here, you want to know if that thing is greater than 8. When you know X is 8 or greater, you want to know if that average is bigger than 8. Okay, statement 1 here tells you the median is 8. So we know X is greater than 8. We want to know if the average is more than 8. Well, so let's just figure out, okay, so we want to know if 23 plus X over 5 is greater than 8, question mark. Well, if it was, 23 plus X would be greater than 40, 5 times 8, and X would need to be greater than 17. Do we know that X is greater than 17? No. We know X is 8 or more, but it could be 10, could be 11, could be 20. So this is insufficient. I know it's not A or D. But now I've already done all the work for statement 2. Statement 2 tells me X is greater than 17. Well, first off, that tells me I'm in the world where X is the median. I have, 1, 4, 8, 10, and then a number more than 17. So 8 is the median. If X is 17, I already know that's going to make the average more than 8. And so the answer here is statement 2 alone. It's B. So when you have a set and you're dealing with a median, but you don't know what one of the numbers is, consider where it could go and what medians would be possible. Either the median's 4, or it's X, or it's 8. And X would fall less than 4, in between, or more than 8. And this game just kind of repeats for the other questions. Okay, same kind of setup, same top there. We don't need to change that. Okay. We just have to consider the possible worlds. Well, statement 1, this one's kind of tricky. Statement 1 tells me X is less than 6. That allows 2 possibilities. Because first off, I didn't mention this, but positive integers, X positive integers. That is a huge thing to note. X is a positive integer. Note that, it's big. So there's 2 possibilities here. Either X is 5, right? X could be 5, in which case the median is 5, because that's this world. Well, 23 plus 5 is 28 divided by 5 is greater than 5. So in that case, the answer is yes. But x could also be 4 or less. Okay. Well, let's say x is 4. Then the median is 4. Is 27 over 5 greater than 4? Yes. What if x is 3? Is 26 over 5 greater than 4? Yes. Since x can't be negative, the median is always going to be more than 4. This is sufficient. So I'd be down to A or D. Statement 2 tells me the median of the set is 4. Well, that means x is 1, 2, 3, or 4, because again, this is important, positive integers. If you didn't know x was a positive integer, that's a totally different situation. This would not be sufficient. But since we know that x must be positive, the absolute smallest thing it could be is 1. Well, then the average would be 23 plus 1 over 5. Is that greater than 4? Yeah. And that's the absolute smallest x would be. X could go up to 4, and the answer is always going to be yes. So the answer here is also D. I think the tricky one here is statement 1, where you have to consider the two worlds, one where x is between 4 and 8, and then one where x is less than 4. But in either situation, the answer is yes. And last but not least, we're going to look at the last version of this question. Same setup. We are still told x is a positive integer, and that is still worth knowing for sure. Try to make a question that dealt with each of the 3 sections fully. So here we have the same situation. We want to know, statement 1 tells us either x times x plus 1 or x times x minus 1 equals 42. Well, that could be 6 times 7 or 7 times 6. X could either be 6 or 7. And then that tells us we're in the middle world. We know x is between 4 and 8. So let's say x is 6. Well, the average is 23 plus 6, 29 over 5. Is that greater than 6? Okay, the answer is no. The median is not greater than 6. The average is not greater than the median. If x is 7, that would be 30, 23 plus 7 divided by 5. And I want to know if that's greater than 7, because it's a new median. And the answer is still no. So this is sufficient. Remember, if you have a firm no, that's just as sufficient as a firm yes. And the only 2 cases here, in the key is you have to note that the median changes. In one, the median is 6, and the next, the median is 7. In either case, the average is less than the median. Here, it's really close, but it is less than 6. Here, the average is 6, and that's less than the median of 7. Okay, statement 2 tells us x is a multiple of 7. Well, is it 7, which would put us in the middle situation, and the answer would be no? Or is it 77, which puts us in the last situation, and the answer would be yes, that is insufficient. So the answer here is A. Okay. And you could, by the way, you could just use the formula and set it. Is it greater than 4? Is it greater than x? Is it greater than 8? And do some algebra. And you're going to realize that in the first situation, you need to know that x is greater than -3. But since x is positive, it's always going to be greater than -3. So if the median is 4, the answer is going to be yes. Here, you're going to realize it's going to say, is x less than 5 point something? Basically, is x 4 or 5? If x is 4 or 5, the answer is yes. If x is 6 or 7, the answer is no. In this last situation, it's going to be, like we said before, is x greater than 17? These are the situations that would have an answer of yes to the question that the average is more than the median. pure algebra though. You don't need to do it. Okay, gang. So wrapping this up. Whew, what a long day that was. Some takeaways. Averages are the balance point. Anything above the average must be balanced by values below. Okay, adding to something must take something away. Shows up a lot. It's a useful thing to remember because you don't have to actually calculate averages to use this idea. Put sets in order from least to greatest and consider possible medians. That's a common one. Don't mistake the range for the number of numbers. I do set that trap. Visualize the set. Even if it's a big set like that one that had how many yacht owners, we didn't know, but just visualize it. Put down some sort of representation and use anchors like the minimum and the maximum and the median to get a sense of what that looks like. In consecutively spaced or just in balanced sets, don't have to be consecutively spaced. The median equals the average. If it's an odd number of numbers, the median is in the set. If it's an even number, the median is not in the set, unless the two in the middle are equal. That's the one time the median is in the set in that situation. And then the tips from set building, the median is the fixed point. A fixed average fixes the sum. You have to be adding and subtracting at the same time to keep it that way. When making something small, make the other big, vice versa, test extremes. And if you do have a set of numbers with an average, if you add numbers to the set with the same average, the average doesn't change. And if you take numbers out that have the same average, the average doesn't change. Okay, so that is all about averages, sets, and medians, and a little bit about range as well. All right, I hope this was useful. I hope it's changed the way you kind of thought about approaching some of these questions and maybe breaks the tendency to do pure algebra all the time. And there's also just some good GMAT common traps in there to remember, like test cases, prove the different possibilities, thoroughly work out the situation. Don't jump to conclusions too fast. That's always a big thing to look out for on the test. Check out for our upcoming courses here at that link. Remember, you can take the first one for free. Hope to see you in some of those sessions. I'm going to go ahead and end the recording. Thank you all for being here, and I will see you next time.